An equation is a statement with an equal sign, and oftentimes when we, in math or algebra, when we have equations with equal signs and variables, oftentimes we want to solve them. And solving means find the solution, find the value of any unknown. So when I say solution, a solution is the thing that will make the statement true. Oftentimes in math there are many things that will make a statement false. That's not as interesting as what will make the statement true. So there's a few types of equations: an inconsistent, conditional, and identity equation. An inconsistent equation is one that has no solution, which means that you could never find a value of x that would make the statement true. For example, x equals x plus 1. I challenge you to find a value of x that you could plug into that equation that would cause the statement to be true. It will never happen. That statement can never be true. It will always be false. Therefore, it is inconsistent. A conditional equation can be true, conditioned upon x equaling a specific value or values of x. So for example, x equals 7, perhaps the equation is true, but only when x equals 7. And then last, we have an identity. An identity is always true. So it doesn't matter what value of x you plug in, you're always going to get a true statement. For example, x plus 3 equals x plus 2 plus 1. I challenge you to find a value of x that you could plug in there that would give you a false statement. It's impossible. It will always be true. It doesn't matter the value of x. It's always going to be true. So therefore, we say there are an infinite number of solutions to the equation, and you can also say that all real numbers is the solution. Example 1. Solve the equation 3 times the quantity 4x plus 28 equals 12x plus 84. I want to note that this is a linear equation, and we are going to solve for x. We're going to isolate x on one side. So the first thing I'm going to do is distribute the 3. So when I distribute the 3, that gives me 12x plus 84 equals 12x plus 84. Some of you may be able to identify at this point that this exact same quantity on the left is on the right as well. If you didn't notice that, then maybe you would subtract 84 from both sides. I don't know what you might do, but maybe that's what you would do, and that gives you 12x equals 12x. Again, we identify that the same quantity is on the left-hand side as it is on the right-hand side. So again, we're isolating x, we're solving for x. So I want to isolate x on one side, so maybe I want to put the 12x that's on the right-hand side over on the left. So I subtract 12x from both sides, and something interesting happens. The variable that I'm solving for goes away, and I'm left with a statement that is 0 equals 0. So this is an example of an identity. So this equation is an identity. The reason why it's an identity is because I am left with a true statement. So 0 equals 0 is a true statement. The x's go away, so that means that it doesn't matter what x you put in, it's always going to be a true statement, which is why it's an identity. You could also say that the solution is all real numbers if you wanted to. And I want to point out that some of you may have been able to see from that very first step when the left-hand side was on the the left-hand side was the same as the right-hand side, whenever that happens, you're going to end up with an identity. Example 2. Solve the equation, the quantity x plus 1 divided by 4 equals 1/6 plus the quantity 2 minus x divided by 3. I want to note that this is a linear equation, and we are going to solve this first by a method called clearing fractions. So we're going to clear fractions. And the reason why I'm clearing fractions is because the 4, 6, and 3 in the denominators, I don't like those. This would be much more simple and straightforward to solve if the 4, 6, and 3 in the denominators were not there. So we're going to clear fractions to get rid of them. And here's how we get rid of them. I take the LCD of 4, 6, and 3, which is 12, and I multiply every term by 12 or 12 over 1, same thing. So that means I multiply all 3 terms by 12 or 12 over 1, and anything with more than one term gets parentheses. So that leaves me with 12 times the quantity x plus 1 divided by 4 equals 12 times 1 divided by 6 equals, plus 12 times the quantity 2 minus x divided by 3. So now if I take a look at those denominators, in the first term I have a 12 divided by 4, that's 3. In the second term, 12 divided by 6 is 2. And in the third term, I have 12 divided by 3, that's 4. So now I'm going to write what I have left. 3 times the quantity x plus 1 equals 2 plus 4 times the quantity 2 minus x. So this is an equivalent equation involving x, and it's much easier or more simple to solve than the original one with the denominators of 4, 6, and 3. So I'm now going to solve for x, so I'm going to distribute the 3 and distribute the 4. And when I do that, I will get 3x plus 3 equals 2 plus 8 minus 4x. So now I want to simplify both sides of the equation. I notice that on the right-hand side of the equation, I can combine like terms. 2 plus 8 gives me 10. So I now have 3x plus 3 equals 10 minus 4x. So I have the left and right hand sides are both simplified, and I notice that I have x's on both sides of the equation. It doesn't matter which side you collect your x's on. It is a best practice, however, to collect your x's on the side where there already are more x's to begin with. So on the left hand side I have 3 x's, on the right hand side I have negative 4 x's. That means I have more x's on the left. So I want to move all my x's to the left hand side, so I'm going to add 4x to both sides, and that leaves me with 7x plus 3 equals 10. So now I'm going to subtract 3 from both sides. That leaves me with 7x equals 7. Dividing both sides by 7 gives me x equals 1. Now this is my proposed solution, and of course we always have to check our solutions, so let's check that. When we check a solution, it's a best practice to plug it into the original equation that we were given. So the original equation was the quantity x plus 1 divided by 4 equals 1/6 plus the quantity 2 minus x over 3. So now if I let x equal my proposed solution, which is 1, and I plug in, I have 1 plus 1 divided by 4 equals 1/6 plus 2 minus 1 divided by 3. So let's simplify that. On the first term, I have 2/4, which simplifies to 1/2 equals 1/6 plus, and that term, the third term, in the numerator I have a 2 minus 1, so that gives me 1/3. So I'm looking to see, is this a true statement, because if x equals 1 is a solution, then it will make the statement true. So on the right-hand side, I need to combine those two fractions. I need to add them. In order to add fractions, we have to have common denominators, which I don't have. I have a 6 and a 3. So I'm going to turn that 3 into a 6 by multiplying it by 2, but not for free. How I pay for that is I multiply the numerator also by the same quantity, 2. So I now have 1/2 equals 1/6 plus 2/6. So I now have common denominators on the right-hand side. So now I can add or combine the numerators, and I now have 1/2 equals 1 plus 2 gives me 3, and then I just write the denominator once. And I can see that the right-hand side does in fact simplify to 1/2. That is a true statement. Therefore, x equals 1 is also a solution. And we can write it, our final answer is x equals 1, or we can write it in set notation, which is grouping symbols around the 1. And so however you write it, 1 is our final answer, and I want to note that this is a conditional equation. It is true conditioned only upon only if or only when x equals 1. Example 3. Solve 2 divided by the quantity x minus 2 equals x divided by the quantity x minus 2 minus 2. I want to note that this is a rational equation. It's not a linear equation, it's a rational equation. And I know it's a rational equation because it has a variable in the denominator. So if I look at the denominators, they're both, they're x minus 2, and then underneath the 2 there's an invisible 1. So I want to do the same strategy as I did for example 2. I want to clear fractions. Now, I note that the LCD is the quantity x minus 2. But before I clear fractions, I also want to note that since this is a rational equation and there's a variable in the denominator, I now have lost control over what quantity is in the denominator, and I run the risk of the denominator equaling 0. You cannot divide by 0. Division by 0 is undefined. So when I'm dealing with a rational, or when I'm solving a rational equation, I have to always note what x should not equal. So if I look at the quantity x minus 2 in the denominator, it should not equal 0. I don't want the denominator to equal 0. So if I solve that for x, I see that x should not equal 2. So I'm going to keep that in mind as I solve this equation. All right, so the LCD is the quantity x minus 2. And since it has more than one term, I'm going to put parentheses around it. So we're going to multiply all 3 terms by the quantity x minus 2 to clear fractions. And when I do that, I'm left with 2 times the quantity x minus 2 divided by the quantity x minus 2 equals x times the quantity x minus 2 divided by the quantity x minus 2 minus 2 times the quantity x minus 2. Now that looks like a lot of things, like a big mess, except that we notice that the denominators cancel, leaving me with 2 equals x minus 2 times the quantity x minus 2. Now that statement is not equivalent or identical, it's not the same as the original equation because I lost information along the way, and what I lost was that x should not equal 2. However, this is easier to solve than the original, so I am going to solve this, and I'm just going to keep in mind that x should not equal 2. So I'm going to distribute the negative 2 on the right hand side. That leaves me with 2 equals x minus 2x plus 4. I'm going to combine like terms on the left and right hand side. On the right I have 1x, and I take away two x's, so that leaves me with 2 equals negative x plus 4. And I have 0 x's on the left, negative 1x on the right. So technically I have more x's on the right. So I want to move that x over. I'm going to move that x over by adding x to both sides. So on the left I have x plus 2, and on the right I have 4. And now I can subtract 2 from both sides. And that leaves me with x equals 2. Now, x equals 2 is a solution to that problem, not to my original problem. So I have to compare the two, and I notice that, so my proposed solution is x equals 2, but I know that x should not equal 2. Therefore, we're going to reject x equals 2, and since I don't have another solution to present, there are no solutions. So no solution is my final answer. And I want to note that this is an inconsistent equation. Example 4, solve 1 divided by the quantity x plus 6 minus 3 divided by the quantity x plus 4 equals negative 2 divided by the quantity x squared plus 10x plus 24. So I want to note that this is a rational equation, and the reason why it's rational is because there's a variable in the denominator. Now, the moment there's a variable in the denominator, I lose control over what the denominator is, and I run the risk of it equaling 0. Division by 0 is undefined. So I want to I'm going to clear fractions, but before I do that, I want to know what x should not equal. And I have a hard time, I can see here in that first denominator, x plus 6, that x should not equal negative 6. And in the second denominator, I see that x should not equal negative 4, or else we'd have a 0 in the denominator. But it's a little tricky to see what would cause that third denominator, x squared plus 10x plus 24, to be 0, and the reason for that is because it's not factored. So let's factor that third denominator. So on the left I have 1 divided by the quantity x plus 6 minus 3 divided by the quantity x plus 4, and on the right on the denominator I'm looking for two numbers that multiply to 24 and add to 10. Well, that's positive 6 and positive 4. So on the right hand side I have negative 2 divided by the quantities x plus 6 times the quantity x plus 4. So I'm going to clear fractions, and to do that I note that the LCD is the quantity x plus 6 times the quantity x plus 4, and I also note that x should not equal negative 6 or negative 4, or else our denominators will equal 0. So I'm going to multiply all three terms by the LCD, and when I do that I have 1 times the quantity x plus 6 times the quantity x plus 4 divided by the quantity x plus 6 minus 3 times the quantity x plus 6 times the quantity x plus 4 divided by x plus 4 equals negative 2 times the quantity x plus 6 times the quantity x plus 4, all divided by the quantity x plus 6 times the quantity x plus 4. So that's what the equation looks like when I multiply every term by the LCD. I put the LCD in the numerator of every term, and it looks like a mess, except watch how nicely things cancel. So when I write what I have left over, that's 1 times the quantity x plus 4, which is just x plus 4, minus 3 times the quantity x plus 6 equals negative 2. Now, that equation is much more straightforward than to solve for x than the original one. So we're going to solve it for x, except that we note that it's not the same as the original. The information that got lost along the way was that x should not equal -6 and -4. So as I solve this equation, I'm going to keep in mind that x should not equal 6 or -4. So solving the equation, I'm going to distribute -3, and I get x plus 4 minus 3x minus 18 equals -2. Combining like terms, on the left-hand side, I have 1x, and I take away 3 x's, so that gives me -2x. Combining like terms on the left-hand side, I have 4 minus 18, that's -14. So on the left-hand side, I have -2x minus 14 equals -2. Solving for x, I have more x's on the right, so I want to move the x's over to the right, so I'm going to add 2x to both sides. That leaves me with -14 equals -2 plus 2x. So now I'm going to add 2 to both sides. That gives me -12 equals 2x. Now I'm going to divide both sides by 2, and that gives me x equals -6. But now I need to compare, right? Because my proposed solution is -6. So I look back up and I see that x should not equal -6. So I must reject x equals -6. And since I don't have another solution to put forward, there is no solution. So no solution is my final answer, and I'm going to note that this equation is inconsistent. Example 5. If y1 equals 12 divided by the quantity x minus 9 and y2 equals 6 divided by the quantity x minus 9, then find x when y2 is 3 more than y1. So this, we have to do a little bit of work to set this up first. So I want to look at the part of the equation, or sorry, the part of the question that says 3 more than y1. 3 more than y1 is 3 plus y1, or y1 plus 3. So is equals, so we have y2 equals 3 plus y1. So that's how I'm going to start. y2 equals 3 plus y1. Well, I know what y sub 2 is. It's 6 divided by the quantity x minus 9, so I can plug that in. And on the left-hand side of the equation, I get 6 divided by the quantity x minus 9 equals 3 plus, and then I have y1. And I know what y1 is. It's 12 divided by the quantity x minus 9. So I can plug that in and get 12 divided by x minus 9. So I now have the equation 6 divided by the quantity x minus 9 equals 3 plus 12 divided by the quantity x minus 9. So this is an equation similar to the ones that we've already been solving. So this is a rational equation. So since it's a rational equation, I'm going to have to state what x should not equal. And in this scenario, x should not equal 9, or else the denominator will go to 0. And I want to clear fractions. And to do that, I'm going to multiply all terms by the LCD, which is, the LCD is the quantity x minus 9. So since our LCD has 2 terms in it, we're going to put parentheses around it. So I'm going to put in quantity x minus 9 in all the numerators. So I have 6 times the quantity x minus 9 divided by the quantity x minus 9 equals 3 times the quantity x minus 9 plus 12 times the quantity x minus 9 divided by the quantity x minus 9, which is a lot of work, except for this cleans up really nicely. The denominators all cancel out, leaving me with 6 equals 3 times the quantity x minus 9 plus 12, which is a much more straightforward equation to solve for x than the original, except they're not the same. We lost information, and the information that we lost along the way was that x should not equal 9. So we're going to solve this current equation, but we're going to keep in mind and remember that x should not equal 9. So solving this equation, I'm going to distribute the 3. That gives me 6 equals 3x minus 27 plus 12. And combining like terms on the right-hand side, I have a negative 27 plus 12. So I now have 6 equals 3x minus 15. I have more x's on the right, so I'm going to add 15 to both sides. That gives me 21 equals 3x. Dividing both sides by 3, I get x equals 7, and then I have to remember to compare. And those statements do not contradict each other. I do not need to reject x equals 7. So x equals 7 is the answer, or said another way, in grouping symbols, 7 is the solution. So this statement is conditional. Just as a side note, this equation is conditional, and it's conditional because it's true conditioned only when x equals 7.